Howdy and welcome back. So I'd like to continue on with the binary number system, and we're going to go ahead and talk about different conversions of going from base 2 to base 10. So from a binary number to a decimal number, and then we'll also talk in this video about going from a decimal number to a binary number. And this is kind of helpful as we're working through our representations of data in the computer, because we're going to be storing our values in binary. It might be kind of nice to think about what that binary encoding is in the decimal system that you're familiar with, so the base 10 system. So binary to decimal conversion. So a binary number can be converted to base 10 by writing in expanded form and calculating just by decimal arithmetic. So we already introduced that. We had, I think, 1, 0, 1. We said we could go ahead and expand this out. We'd have 1 times the base to the position plus, in this case, the second digit there, 1 plus 2 to position 1 plus 1. Oops, that was multiplication. 1 times 2 to the 2. And if we were to go ahead and add all of that up, we'd encounter the integer value of 5. So what we can also do is kind of follow a more algorithmic approach. This might be helpful if we have an activity where we're asking you to program a binary to decimal calculator to go ahead and convert binary input into the corresponding decimal value. So this is kind of fun. We have some sort of value here. So 1, 0, 1. And this process begins as follows. We double the leftmost digit. So we double that 1. That's going to be 2. We're going to go ahead and add 2 to the next digit, which is going to be 0. Just grabbing some different colors here. Let's use pink. 2 plus 0 is going to be 2. And then we go ahead and double that sum. So 2 doubled is going to be 4. And then we can go ahead and add that to the rightmost digit, and we will arrive at 5, which is the decimal equivalent of the base 2 number 101. Okay, so that's how we go from binary to decimal. What we might also be interested in is how we can go from decimal to binary. So there's many different ways to do this. I find this kind of the most straightforward and perhaps easiest to think about. So if we have some sort of decimal value, let's say, I don't know, 30. And we want to go ahead and convert 30 into a binary, into the equivalent binary value. So what we're going to do is subtract the largest possible power of base 2 from M1. So what is that? If we go ahead and start out, we have 0, 2, 4, 8, 16, 32. So that looks like, and that's so 0, 1, 2, 3, 4, 5. Those are the exponents there in the bottom. So 2 raised to the 4 is going to give us 16. So let's go ahead and subtract 16 from 30. So that gives us 4, 14. So notice we've already put into this 2 to the 4. And we're going to go ahead and remember that, because what we're going to see here is when we look at the base 2 representation, it's just kind of on and off in terms of what powers of 2 did we have to subtract this until we observed a 0. So kind of going through this, okay, 14, just looking at my little table there, it looks like 8 would be the next. Let me use a different color. So 8, that's, if we remember here, that's going to be 2 to the 3. Okay, so 8 subtract 14 is going to give us 6. And we continue this process. So what is the largest power base 2 that can go into this? Well, it's going to be 2 to the 2, or 4. So let's go ahead and subtract 4. That was 2 to 2. So that's going to give us 2. And then to go ahead and get 0, what we're going to do here is, well, 2 to the 1. So that's going to be 2 whoops, 2 to the 1, and that gives us 0. So what we've done is we've just subtracted the largest possible power, base 2, from 30. We then subtract the largest possible power of base 2 from the result, and we continued this process until we observed a difference of 0. So that's when we stopped. So what we've noticed here is we've had to, the different powers of 2 that we used in this conversion are 2 to the 4, 3, 2, and 1. So if we go ahead and write that out, so I'm going to go ahead and write 2 to the 5, 2 to the 4. You know what? Let's do it this way. This will make more sense. 0, 1, 2, 3, 4. We'll just go up to 5. Okay, so these are the exponents or that we raised the base to. And which ones did we use? We did not use 2 to the 5 anywhere, so that's going to be a 0. We did use 2 to the 4, so that's going to be a 1. We did use 2 to the 3, that's going to be a 1. We did use 2 to the 2, so that's going to be a 1. And we did use 2 to the 1, but we did not use 2 to the 0. So the binary equivalent of 30, of decimal value 30, is going to be 0, 1, 1, 1, 1, 0. And notice here that after I figured out, these large kind of consistent possible powers of 2, this repetitive subtraction process, all I did was place a value of 1 in the place value of those powers subtracted and a bit value of 0 elsewhere. And that's what we did right here. Okay. So that closes out our brief discussion on converting binary values to their decimal equivalents and then decimal values to their binary equivalents. In the next video, we're going to talk briefly about binary addition. So I'll see you all there.